Hello, this is Josh Kramer, and today I'll be solving my homework 3 in my Transport 1 class at the University of Cincinnati. So this problem gives us two tanks. I will draw here, and they're filled with fluid. And each tank respectively has a height. So this one is going to be H1 because it's tank 1, we're assuming. And this one is H2 for tank 2. And each tank has a cross-sectional area of A. So we have A1 for tank 1 and A2 for tank 2. And then we have an inlet flow into tank 1 with a flow rate of Q1. So that doesn't look very good. Let me just... An inlet flow rate of Q1, and it has a transfer flow rate between the tanks of Q1, 2, so Q from tank 1 to Q2, and this is flow rate. And then it has a flow rate out of tank 2 with the flow rate of Q2. So we can make a few assumptions here. So the major assumption that we're going to make is that this process is going to be steady state. So what steady state means is that the flow going in is going to be equal to the flow going out. And in this case, we can attribute that to the flow rate going in is equal to the flow rate going out. Or otherwise, you could say Q1 minus Q2 is equal to 0. So, but we do know we know some of the values of these. So we know that Q1, or we don't have a value for Q1. So that is in the air, but Q1, 2 and Q2 we do have values for. So we know that Q1, 2 is going to be 1/2 H1 minus H2, and we know that Q2 is going to be equal to 1/4 that the square root of H2. And an equation that we're going to be using today to help solve this is the velocity is equal to the area times the height. And so our T1 here is going to equal the change in the velocity of 1 over dt. And using this equation up here, we know that the velocity of 1 is just equal to the area of 1 times the velocity of 1, and that's dA1 v1, and then that's over dt. So the change of area times the height, I wrote velocity, change in area times the height of 1 over time is equal to the change in velocity over time. And that is equal to Q1 minus Q1, 2, so the transfer. So what we're showing here is the difference between the inlet flow and then the transfer flow. However, we do know that the cross-sectional area here is going to be constant in tank 1. So the area is constant, and because it's a constant, not a variable, we can transfer to the other side. So that's what we're going to do. So we know that now the change in height, the change in height is just equaling the change in water level. So the height is the water level, and that is going to be equal to Q1 minus the transfer flow between 1 and 2 all over A1. And I did make a mistake over here. Since it's constant, it's not a changing variable, so it's going to be like dH1 times A. So that's what we have for tank 1 to tank 2, and so now we're going to solve from the transfer flow out. So that we're going to call that T2, and so we're just going to use the same basic equation. So t or the change in velocity of 2 over time, and that's going to be equal to the change in height of 2 times the area of 2 over the change in time. We're just going to do the same thing. So the area is constant. The cross-sectional area of this tank is not going to be changing, so that's constant. And so we can just do the same thing by bringing it over. So we have Q12 minus Q2. And by dividing this over, we have our new equation, dH2 over dt is equal to Q12 minus Q2 all over A2. So what we're going to do now is we're going to go over to Python and we're going to solve this equation.